Ladies and gentlemen, please join me to welcome Dr. Vikram Venkateswaran.
Hello and a warm welcome to all of you. And thank you for this opportunity to present my perspective on how we should handle security, especially in embedded medical devices and other classification of devices as well. As you know, the healthcare industry is having a major transformation as we speak. We are battling a pandemic which is pretty much worldwide. And at the same time, there have been a lot of changes in the medical devices field as well. We have seen the emergence of software as a device. We see a lot more embedded devices today than before. And we also see a big growth in the personal health device space, where a lot more users are buying devices to monitor their health continuously. So what do all these changes mean, and how is it impacting the way we look at device development, especially from a security angle? I will try to refrain from talking about privacy too much because that is a topic that has been discussed extensively. And that's more or less a question of getting the right controls in as per the country legislations. But at the same time, let's look at what's happening in the medical device world. What are the changes that the market is driving, and how can device manufacturers and developers learn from that? So my name is Dr. Vikram Venkateswaran. I have about 20 years of consulting experience, including 6 years in the clinical practice. I graduated from Manipal on the west coast of India. I went on to do my MBA from IMT Ghaziabad. I've worked with major healthcare systems in the US, UK, and India. I founded Healthcare India in 2010 with a focus on looking at public policy implications for technology and how to embed standards into the healthcare scenario in India. I do sit on some major industry bodies, including IET, FICCI, ASSOCHAM, and the Bangalore Chamber of Industry and Commerce. This year, I was declared as one of the top 30 healthcare influencers. So that probably will help me further take the message of technology, safety, privacy in the healthcare space. And last year, I released my book, Own Your Health, which is out on Amazon. So it gives me great pleasure to talk to you, not only as a clinician who's used devices, but also as a consultant and a technologist who's been working with healthcare systems. So I know both sides of the fence. I know what it takes to develop a device, and I know what it takes to use a device, and how to navigate that transformation from creating something apt for the market to ensure that it is safe, it is easy, it is secure to use. Well, I don't know how many of you recall this incident, or post-COVID, all of these incidents seem to be lost in our memory. But about 2 years ago, a major device manufacturer had an issue so serious that they had sent out notifications to all their patients who were using this particular device. In this case, it was a pacemaker, to come back for an elective surgery, a planned elective surgery to replace the pacemakers. What was the challenge? Was the pacemaker faulty? No, it was not faulty. Was the pacemaker not doing its job? That was not the case at all. There were no functional issues with the pacemaker. What had happened was the code of the pacemaker had been leaked externally. And it was available on the black market. And it was seriously believed that hackers would now hack into your pacemaker and manipulate its functioning. What I'm talking about is not science fiction. This incident actually happened. And there were massive recalls. When you recall a car, you just leave the car back at the dealership. When you recall a pacemaker, you have to get the patient back into the hospital, remove the pacemaker, and put a new one. Not an easy task. And it becomes even more difficult if the user or the patient using your pacemaker was a former US president. The picture on my left is former US Vice President Dick Cheney, who was called in because his pacemaker was leaked. The data was available on the darknet, and people could hack into it. And he was given Secret Service security anyway. He had high level of clearance. And together with the president at that time, he had taken many crucial decisions which could impact many countries. And this was a very dangerous information in the hands of cyber criminals. Today, when you talk about cybersecurity, a lot of us talk about credit card data, credit card numbers, pins getting lost. Nothing compared to the value that healthcare data is on the dark web. It is believed that financial data sells for about $5 to $7 per line item on the dark web, but healthcare data sells at $51. Your data is very valuable, especially healthcare data. It is also called sensitive data as per various classifications. What I just showcased to you is a very extreme case, but it is a reality. And today, as more and more devices are pushed into market, this reality becomes even more worrisome. Let me share some headlines with you. And most of you would have seen this, but these are not created by me specifically for this session. This is all over the internet. This is publicly available information. Look at these breaches. While you can read all of them, let us talk about our own breaches in India. Right? We had an incident with the Beach Candy Hospital where data was breached from the hospital itself. There are many devices in India that were hit, especially stents and very expensive insulin monitors, CCGs, ECGs, CT scans that were breached as well. So why is this happening all of a sudden? And why are we suddenly seeing a spurt in all these devices getting hacked? Number one, the good part is that as healthcare is transforming and adopting more and more digital, this has become a very, very classic case of, I would say, teething troubles or transformational troubles. When we move from a very paper-based system to a digital system, some of these challenges are bound to happen. Healthcare is not the only industry getting hit. Every day you hear of financial services, banks getting hit, you see travel and transportation companies getting hit, you see hospitality companies getting hit. But why it becomes very important for healthcare is that this data can be misused, and the misuse can have serious consequences, even leading to the death of an individual. So while medical devices have become very pervasive, the cyber threats to them have also become very pervasive. So the more you expand your digital footprint, the more chances are that you're going to get hit. So let's look at some of the reasons why this is happening in the healthcare industry today. One is time to market. COVID-19 is a great case in time, where every day we have news items that so many ventilators, so many fibrillators, so many oxygen concentrators have been shipped out. Devices have been produced in a record time. People have converted factories producing, automobile components, other manufacturing things into medical device factories. Blueprints for ventilators were shared, etc., etc. What that means is we are rushing through the production of a medical device. And when we do something in a hurry, we do tend to take shortcuts. And when we do tend to take shortcuts, challenges happen. Our biggest challenge today is time to market, because consumer expectations are so high that they expect the device to be ready in no time at all and to be shipped and available. And while organizations can meet it, the threat, the long-term challenge we have is, have we made the device secure enough? Number two, increasing costs. Costs for manufacturing of devices are going up. Though in a way, sensor technology is getting cheaper and it's much more cheaper to get the sensors in, the overall cost of manufacturing remains relatively high. And this also becomes because you use a lot of technology, which is expensive. You bring in professionals who are highly trained, and that adds on to the cost. and you go through an entire regulatory system, which which for the right reasons have the right checks and balances in place. And while all this is happening, your cost is increasing tremendously. So device manufacturers are always under pressure to look for ways to improve their cost. And that can lead to some of the challenges we're seeing today. The third challenge is probably the biggest, our over reliance on the ecosystem. Now, let me explain what this means. It is commonly believed that challenges in the healthcare ecosystem cannot be solved by just one partner. So you end up working with a wide variety of partners, right? From cloud providers, your technology providers, embedded system providers, hardware providers, chip providers. And as you help them integrate the device together, some of the threats or some of the loopholes that were there in their systems will come into yours. And unless you have a very robust system of checks and balances, that is unavoidable. Number four is regulatory process. We follow a very, very difficult time in regulations because, quite frankly, while manufacturing and software development has moved agile, the regulatory process is still waterfall. They expect everything to be accumulated and shared to them after everything has been done, and then they'll come back with the feedback, which leads to repeated rework, which leads to cost pressures, time to market, reliance on the ecosystem, which leads to further problems. So it's a never-ending cycle, right? And this has its own implications on why device manufacturing today is a big issue. Last but not the least, margins are under pressure. In India, you know that drug price control is in effect on many devices, especially devices like stents. And because of that, there is a constant need to keep the margins fine. Because if you can't charge that much for a stent, then you have to find a way to make it cheaper, which leads to the cost pressures and time to market again. So all of these processes are interlinked, and somehow they are coming together to create a perfect storm in which the security of the device is always at risk. So what does one do? What I'm going to talk to you today about is probably not a new concept. It's probably an old concept. But the challenge is taking a concept like DevSecOps and implementing it in your organization. If you look at any major device manufacturing center today, are they 100% on DevOps? No. They still have traditional waterfall methods running. They still have traditional ways of doing things, which they haven't been able to merge into DevOps. Right? A lot of the digital aspects, like software as a device, which is produced purely in a digital transformation initiative, that can be DevOps. But the rest of it is still following classic waterfall or old methods of agile. And then you have DevSecOps, which is one step ahead of DevOps. So how does one embed security into a DevOps scenario? And how does that work? Let's look at a few things that we have learned. So this is a classic DevSecOps scenario, easy to say, difficult to implement. And I'll give you my reasons. What it means is getting security risk function involved right at the planning stage. I know if you look at a classic software development team, you'll have an SME who understands the patient, you'll have some medical folks who understand how the device should work, and then you have all these development teams depending on the platform you're building it on. You'll have a scrum master, you have an architect, and you have all these wonderful technologists who come together with the SMEs and build it. But there is zero involvement from the security function. I don't know how many of you, think back to your own development, right? When you are developing a software or a device or software as a device, how many times have you involved the security, the risk function right at the beginning, at the planning stage itself? Hey, this is the software we're going to use. This is the methodology we're going to use. This is the database we're going to use. This is our API layer. And ask a security analyst for his opinion, whether this is just right to do, wrong to do. The reason I say at the planning stage is because when we are planning, we tend to use a lot of freeware. For example, say SQL database, which is available, or use Jira, which is open source. I'm not saying that these are bad tools. These are great tools. But are they secure? Do they have ports that are open? Do they have license policies that might put your device at risk in the future? Who is assessing all of those? right at the planning stage, because you can't go to the end of a device and say, okay, this is the device, this is ready. And the security guy says, no, I can't approve it. And then you go back and forth. That is not going to work. So right at the planning stage, you have to get an opinion on security, on device, on the infrastructure, on the application layer, on the API layer, on all the software you're using, the partners you're using, whether the partners have been vetted, the partners have had some kind of a risk assessment done on their processes to ensure they're following it, right? Are we looking at logs that are previously created for our devices to learn more as to what's happening with the security and the privacy of it? Then it comes to the coding stage, and again, every time in agile, whether it's a weekly sprint or a bi-weekly sprint or a monthly sprint, are you doing a code review? Are you doing regression testing as it happens? Are you making sure that a lot of that device, all this code that you're creating, is being stored in a very secure way? And is the security function involved in it? Is the regulatory function involved in it? The answer is no, mostly. If you look at the regulatory function, it pretty much comes in towards the end, but the security function has to be right there in the beginning. And if you can involve the privacy function as well right at the beginning, it's much easier, because you will know which are the privacy laws to avoid, which are the loopholes in privacy that you should not fall into, so that your device development is streamlined and there are no back and forths on it. Then goes to build, test, release, deploy, operate, and monitor. So the security function kind of maps everything. And there are standard processes that organizations use. For example, a good example is secure by design, which is an integral part of most development today, where right in the beginning, you trigger all the security checks and balances that need to be done, whether it's cloud security check, whether it's application security, infrastructure, mobile, API security, and take preventive measures like VAPT or pen testing, or look at red teaming of how you can strengthen and stress harden your device. This is a very important component. So while you're going for DevOps and making the painful migration from doing work in waterfall to DevOps, I think it's very important to immediately integrate a security layer and make it DevSecOps. So what's the advantage? I mean, clearly I can see three. One is security. Your security is baked into your device. You don't have to do a separate security checks. They're already baked into the device. A weekly pen test is an absolute must. I think this is an absolute must for any software, but especially in case of a medical device, I think it's highly mandated. Second is risk remediation. See, when you do DevSecOps, all the risks that are created or identified and the necessary controls that are recommended can be tracked to closure right at the beginning. You're not doing it at the later stage. What typically happens is you have the device and it's ready, and you go to the risk function or security function, and they identify, critical, high, medium, and low vulnerabilities. And then mostly we accept the low and we focus on the critical, high, and try to mitigate the medium. And we try to get into some kind of an agreement saying, okay, in 1 month I will close these ports, or in so and so time I will close that out, or in so and so time I will get those consent mail signed. But that takes time, and that adds to your time to market, that adds to your cost, and that overall adds to the sanctity of your device. Right? So risk remediation is a very important thing. The fact that you have remediated the risk so that in the future, there are no issues from the organizations, there's no issue from the hospitals, there's no issue from the patients, and also no issues from the auditors. Last but not the least, I think the QMS process has to go agile. This has been a constant problem that I've seen, that QMS is still, the quality management system is still following some kind of waterfall, where they wait for all the requirements to be given to them and then they'll start their analysis. QMS has to be baked in again. This cannot be done as an ad hoc standalone process. So in a DevSecOps model, you have your integrated regulatory, integrated security, integrated privacy, and integrated QMS. It has to be integrated into your development process. Development of a device cannot happen in silo. It can't happen that one development team is doing the device development, and then after they are done, they'll toss it over to a security team or a privacy team and ask them to go figure out how to get this to market. That's not how it's going to work. And most of our challenges are coming from there. And this I'm not saying only in terms of medical device. This applies to any healthcare software, your EMR, your EHRs, your telehealth platforms, your telemedicine platforms, all of them. They have to follow this. Otherwise, it's going to be a very painful experience for all those involved, and the most painful for hospitals and doctors and lethal for the patients in some cases. What does it need? Well, what I said in this last 20 minutes was probably all of you know it, right? You always know it as you're manufacturing a device, you're in the development team, or you're in the marketing team, you're in the sales team, or you're an architect. You already know these challenges. So what it needs is a culture of DevSecOps. DevSecOps is not a technology shift; it's a culture shift. It has to happen in the mindset. It might slow down the process initially, but we have to accept it and integrate it and make sure we adhere to it, not make security and regulatory and privacy an afterthought. Second, too, most importantly, if there are leaders here, when I'm talking about leaders, I'm talking about business leaders, I'm talking about those who run the P&L, those who write the checkbook for all this development to happen. You need to buy into this. Without leadership buy-in, it's impossible. Though DevSecOps in a very distributed model is feasible, and there might be individual teams that might succeed in it, but to have an overarching framework in the organization for producing software under DevSecOps will not require leadership change. The leadership has to buy in. Number three, integrate as much automation as possible. I say this with a pinch of salt because automation is not the focus here. The focus is DevSecOps. But without automation, without having an automated traceability metrics, for example, it will be very difficult for you to follow DevSecOps. There has to be a great degree of automation. We have to remove redundant manual processes. Personally, I prefer using something like Azure DevOps board, right? Because it really helps me understand our velocity, our throughput, where we are. But increasing the degree of automation helps us focus on the tasks that are most critical. And that is true even from a development perspective, but very true from a DevSecOps perspective. Last but not the least, there has to be a change management protocol in place. Moving from waterfall to DevSecOps is not going to be painless. There has to be constant communication, learning, training, bringing in experts, talking to agile coaches, bringing in external partners who've mastered this to help you make the transition. DevSecOps is a philosophy. It is not a technology. It is a philosophy that has to be adopted at the highest level. Today, the advantages we see in digital, especially with tech giants like Amazon, Google, etc., is because they adopted the philosophy of DevOps and Agile long before anybody else did. And today they are so successful because they can quickly react to market conditions. Similarly, most medical device manufacturing firms have to shift to a DevSecOps philosophy. And when I talk about medical device, I also talk about health tech. I talk about all the startups that are out there today, talking about embedded systems. I'm talking about EMR development, EHR development, and all of the above. With this, I am really happy to conclude my session. It was a pleasure talking to you, and I hope I have created a sense of urgency in you in how you should approach the security conundrum, in especially healthcare. Right now, I'm open to taking any questions that you might have. Thank you for your time once again.